VLPSos here. This is a video lesson for Python programming, interval collision. This lesson code started with proximity collision. We're going to take a look at this program running and then look at the code to see how we accomplished it. We can see a screen with two rectangles bouncing around. When the rectangles get close enough to touch or overlap, we say they collide, and their collision makes the colors change. Every single frame we detect if the rectangles are touching over or overlapping. There's only one color change per collision or per frame, but we see many changes happening at once when they're colliding for many frames in a row. We can press the mouse button to add more rectangles and see the collisions that are happening between any of them. Let's take a look at the code that accomplishes this. The class that we call thing is used to create instances which are represented as rectangles to the user. The attributes that we'll use in the algorithm to detect collision is the X and Y position, which for a rectangle is the upper left corner, and the width and height, the dimensions of the rectangle. We'll get to the algorithm that we wrote here in its own function in just a minute. We create instances of our thing and put them into a dictionary called population. We have the ability to make more instances by pressing the mouse button, which makes the make thing boolean true and creates another instance and puts it in the population dictionary. We move stuff by a very familiar algorithm that we've been using for many lessons to get them to bounce off the edges of the screen. And here we have the code block for detecting collisions and then creating an interaction when we detect if they've collided. Let's take a look at this algorithm in a little detail. Like proximity collision, we need nested for loops. We've got to choose two keys from the same dictionary of instances. So we iterate through the dictionary once for every instance. We have an iterating variable called key. And for every instance, we iterate a second time through the dictionary to find another key, call that key 2. Now, only on condition that these keys are not the same, because we don't want an instance to collide with itself or detect for that. On condition that the two keys are different, then we go through this process which starts with defining 4 variables that we're going to send to our collision algorithm that's defined separately. The 4 variables are PA and PB, which is the coordinates of the top left corner of that instance. So we have 2 points for the locations of our 2 rectangles, and DA and DB, which are the dimensions of our 2 rectangles. All of these are tuples of 2. Both the points and the dimensions. The dimensions have a width and height. When we have those 4 variables, we send them to the find collision by intervals function that has been defined above, and we'll take a look at that in a minute. If that function returns true, then that means that a collision was detected between the 2 instances that we sent to that function. And if we have a collision, then we choose randomly a couple of colors and reassign the color attribute. That's the color change that the user sees. Let's take a look at the find collision by intervals algorithm. That function is defined outside of our main code loop or code function. The find collision by proximity algorithm is here, but it's not used by this program. We can compare it to the other one, which is new. Here is the find collision by intervals function, and its argument has those 4 tuples of 2 that are being sent to it. We have a couple of comments to remind us what those values represent. And then it has comments and the math and conditions for detecting this type of collision. This is fairly sophisticated, especially if it's the first time or first few times that you have considered this kind of collision. So we will have collision if A and B overlap, and they will overlap or touch if two conditions are met. One, they line up horizontally, and the second condition, they line up vertically. And we are going to test for horizontal alignment and vertical alignment separately, but we need both to be true at the same time for there to be collision. Let's consider horizontal alignment first. Horizontal alignment requires two conditions to be met. One, the x position of A plus its width is greater than the x position of B. And the x position of A is less than the x position of B plus its width. Symbolically, that is this compound condition, where in that condition, P is point information and D stands for dimension information. And of course, they're indexed because every point and every dimension is a tuple of 2. If that compound condition is met, then we could say horizontal alignment is true. Let's talk about vertical alignment. Vertical alignment requires two conditions to be met. The y position of A plus its height is greater than the y position of B, and the y position of A is less than the y position of B plus its height. Symbolically, it's that compound condition. Again, where this information, P for point, D for dimension, and they have indices because each is a tuple of 2. If that is all true, then we'd say they have vertical alignment. Horizontal and vertical alignment visually looks like this. If we have two rectangles, then we'll say they horizontally align if in some way their horizontal position lines up. Horizontal position is not lining up for these two rectangles. But as soon as they get close, they do horizontally align, and they will be horizontally aligned until they're past each other and their horizontal positions are not lining up. Vertical position is similar, but with a different dimension. Vertical alignment is when any part of their heights and location line up vertically. So their vertical positions can change. They will line up vertically anywhere where they are lining up here. There is not vertical alignment when they're past each other or past each other like this. So if two rectangles horizontally align and vertically align at the same time, then they must be overlapping or touching somewhere. So if we have vertical alignment and horizontal alignment and they're both true, then we've detected collision, and in this algorithm we assign the collision variable equal to be true and then return it. So if this algorithm detects that there has been collision, it sends that Boolean value back to where we called this function and then make the changes or effects that the user would see, which is a color change. Let's see the program run again. And it might be worth noting that explaining it and seeing this algorithm with all of its symbols is probably going to confuse almost everybody. This comment here says, lots of confusing symbols. Check out the interval collision tool, a separate program and video that accompanies this lesson and its code, where the user can interact with rectangles on the screen and move them and experience these conditions with the symbols involved in order to better understand what's going on. I recommend looking at that video and code. Let's run this program again. When There's collision, there is vertical and horizontal alignment at the same time, and color change. And we can click to add many more rectangles and watch them all collide. Now you have seen how interval collision can be implemented by using a function that uses the position and dimensions of two rectangles to see if any part of them overlap or collide. The techniques involve checking if any part of the horizontal and vertical intervals overlap. This method is especially good for objects that are rectangular or nearly rectangular. Use this code file as a stub. Make it so that a white rectangle is drawn with its upper left corner at the mouse location, so you can move that rectangle around with the mouse while the program runs. Make it so that if any rectangle moving around touches the white mouse rectangle, it is deleted from the dictionary. Have fun.